All right, so which of the following statements are true about x squared minus 6x plus 2? Well, I need to solve this clearly, all right? But I can also graph it. So I'm going to show you how to complete the square on this. So I'm going to go over to the side. And the first thing I'm going to do is I'm going to write the equation out just the way it is. X squared minus 6x plus 2 is equal to 0. Now, the first thing I'm going to do is I'm going to subtract 2 from both sides. And I got x squared minus 6x, and I'm going to leave a little blank space here, and you'll see why in a second, is equal to negative 2. Now, remember that this is written like ax squared plus bx plus c, where b is the middle term. So in this case, a equals 1. Take your hood down. Thank you. B equals negative 6, and it doesn't matter what C is. B is what we're really interested in, because what I want to do is I want to take B and divide it by 2 and square it, and I want to add that to this. Now, whatever I do on one side of the equation, what do I got to do to the other? Same thing. So I'm going to say B over 2 squared. I'm running out of room, but that's okay. I'll write it on the next line. Actually, let me just make the room. You guys are still writing some stuff down anyways. So I rewrite the line. I'm going to say x squared minus 6x. I'm going to add something there, and I got my negative 2 here. So whatever I add here, I'm going to have to add here. You guys with me so far? Yeah. All right, so now the next thing I'm going to do is I'm going to take b squared, or b over 2, and square it. And whatever I do on one side, I got to do on the other side. So 1/2 of b squared. Well, what's b? Well, that's negative 6 over 2. Well, what's negative 6 over 2 reduced down to? Negative 3 squared. So this becomes negative 6, and you square that. Okay? So the rest of the stuff still stays the same. So this is still x squared minus 6x plus this stuff plus this stuff. And this is equal to negative 2 plus this stuff equal to negative 2 plus this stuff, which is negative 3 squared. Well, what's negative 3 squared? 9, right? Because remember that negative 3 times negative 3 equals a positive 9. So I've got x squared plus, oh no, not plus, minus 6x plus 9 is equal to negative 2 plus 9. You guys with me so far? Now this is a perfect square. This is the same as x plus b over 2 squared. By the way, what's 9 minus 2? 7. But what's b over 2?
8.
Where'd you get 8 from? It's negative 6 over 2, which is negative 3. So this becomes x minus 3 squared is equal to 7. Now, how do I undo a square? Take the square root. So when I take the square root of this side, I got to do plus or minus the square root on this side. So then I'm going to get x minus 3 is equal to plus or minus the square root of 7. What do I do to solve for x? I'm going to add 3 to both sides. Now, when I add 3 to both sides, I kind of ran out of room. I'm going to get x is equal to positive 3 plus or minus the square root of 7. So if we come back here, the question is, the solutions are x equals 3 plus or minus 7. Is that right?
Yes.
Yeah. You think this is a game? Think I'm playing around with this algebra? So now let's check all the other stuff, because that's one of the things for sure. So this says that's one of them, and then the other thing as I read this, it says the graph has a quadratic equation has a minimum value. Well, we know that a quadratic has a minimum value. How do we find the minimum value?
Over, or if it's sloping down, it's sloping up.
Yeah, we're going to have to graph it, but we can find it. But this also says it has an extreme value at 3, negative 7, or 7, negative 3. So is this going to have a minimum or a maximum, though? How can I tell?
The x is either positive or negative.
So here's what I want you to know. A tells us if it's minimum or maximum. Is A greater than or less than 1 or 0? A is greater than 0. If A is positive, it opens up like this. So that would be a minimum. So the graph definitely has a minimum value because it's quadratic. It doesn't have a maximum. The only way it would have a maximum is if A was negative. Somebody made a simple mistake. So now we got to determine what the vertex is. So it's either 3, 7 or 7, negative 3. Well, I'm just going to graph it. So another thing, we've been using our calculators a lot, but another nice program is Desmos. And Desmos is pretty cool because I could just graph the equation and see where it crosses the y-axis. So if I say x squared minus 6x plus 2, this is what I'm looking at. What's this right here? Oh, 3, negative 7. You think this is a game? Think I'm playing around?
No.
I don't know why you guys came to school, but I came to do math. So this is the minimum, right? Mr. Adams said there was a minimum for sure. But why do they call it the extreme value? Why are they using the word extreme value? Well, we know that the extreme value exists at 3, negative 7, right? And not 7, negative 3. But what does it mean by extreme value? Well, it's the minimum. It's a minimum because it is the minimum value for y. Is there going to be a y value lower than this?
No. Negative. I think it's me. I gotta go home.
Hold on 1 second. Close, Mr. Adams. Okay, bye. So this minimum value across the entire domain. When I say entire domain, what does that mean? What does the domain refer to? The domain is all possible x values. It's the whole graph. So when I look at the whole curve, or the whole graph, but technically the math term that we say for graph would be curve because we're looking at the red line. For the whole curve, the lowest y value is going to be negative 7. There isn't going to be a y value lower than negative 7. And if you just look at the graph, you can see that, right? So that's why it's called an extreme value. There are other values that are low, but that is the extreme. That is the lowest. There isn't going to be another one lower than that one.